In this video, let us learn the second derivation of this chapter, that is electric field at a point on the equatorial line of an electric dipole. This question is again asked for 5 marks in our examination. Now, let us understand the derivation with the help of a diagram. In a diagram, this is a positive charge and this is a negative charge, which are separated by a distance of 2a. And this is a midpoint of a dipole. Now, what is equatorial line? A line which is bisecting the dipole perpendicular to the dipole axis is called equatorial line. So you can observe in the diagram, the line PO is bisecting the dipole at its midpoint. So this line can be considered as an equatorial line. Now, the point P is at the equatorial line and we should find the electric field at this point due to the two charges. So before going to that, let us find what is the distance of this point P from either of the charges. Now you can look at a right angle triangle APO. APO is a right angle triangle. This is R and this is A. Now, according to Pythagoras theorem, this is a diagonal side and this distance must be equal to root of R square plus A square. So this distance will become root of R square plus A square. Now, the point P is at the same distance from either of the charges. So from A to P or from B to P, the distance is same. Now, let us find the electric field at P due to negative charge which is placed at B. So we are finding electric field at this point due to negative charge. What is the equation? 1 by 4 pi epsilon naught into Q into 1 divided by R square plus A square, because this distance is root of R square plus A square. So if you square this term, you get R square plus A square. Therefore, this is R square plus A square. Now the direction of this electric field E1 is along PB, because you know that electric field due to a negative charge is directed towards the charge. Okay, this is directed towards the charge. Now, similarly, electric field at point P due to positive charge which is placed at A. We are finding electric field due to this charge now. The equation is E2 is equal to 1 by 4 pi epsilon naught into Q into 1 divided by the same distance R square plus A square. And this electric field is along AP. This is AP because you know that due to a positive charge, the electric field is directed away from the charge. Now at point P there are two electric fields. One is E1 which is directed towards the charge and other one is E2 which is directed away from the charge. Now E1 at point P is resolved into E1 cos theta and E1 sin theta. Similarly, E2 at point P is resolved into E2 cos theta and E2 sin theta. Now look at the diagram again. You can observe there is an electric field here, E1 here, correct? E1. So this E1 is resolved into two components. One is E1 cos theta, other one is E1 sin theta. Okay, so we have resolved this vector into two components. In the same way, E2 is also resolved into two components. This is E2 cos theta and this is E2 sin theta. Now, by looking at the diagram, you can clearly say that E2 sin theta and E1 sin theta are opposite vectors. They get cancel each other. But at point P, the two vectors E2 cos theta and E1 cos theta are acting in the same direction. Therefore, they get added up. So, the net electric field at point P will be E1 cos theta plus E2 cos theta. Now, look at this one. So that is what we have written here. E1 cos theta plus E2 cos theta. Now, Let us substitute this E1 by 1 by 4 pi epsilon naught into Q into 1 divided by R square plus A square. So we have substituted from this equation, E1 and E2. Yeah, E2 is again 1 by 4 pi epsilon naught into Q into 1 divided by R square plus A square into cos theta. Now, if you add these two terms, you get 2 into 1 by 4 pi epsilon naught into Q divided by R square plus A square into cos theta. Now, so by the diagram, what is cos theta for this theta? I mean for this triangle. So what is the cos theta for this triangle? So you know that cos theta is adjacent side by hypotenuse side. So you know that this is an adjacent side, this is adjacent side, and this is hypotenuse side. So we have already written what is the hypotenuse side is. This is root of r square plus a square, right? So cos theta in this triangle will be a divided by root of r square plus a square. So that is what written here. You can observe here cos theta is a divided by r square plus a square to the power of 1 by 2. Now cos theta is again substituted as a by r square plus a square to the power of 1 by 2. Now rearrange the equation. Let us take the 2 inside the bracket and also a inside the bracket. So the equation becomes 1 by 4 pi epsilon naught into q into 2a divided by r square plus a square to the power of 3 by 2. Because here we have power 1 and here we have power 1 by 2. So these are two same terms. So if you multiply these two terms, the powers gets added up. Therefore 1 plus 1 by 2 is 3 by 2. Now let us write this q into 2a as p. You know that p is a dipole moment. So dipole moment p is equal to q into 2a. Therefore let us substitute this q into 2a by p vector p here. So finally the equation becomes E is equal to 1 by 4 pi epsilon naught into p divided by r square plus a square to the power of 3 by 2 Newton per coulomb along px. So what is the direction of this electric field? Look at the diagram. Px, this is the direction of electric field px. So that is what written here. Okay, so this is the derivation. Now let us consider the special case of this derivation. That is, if r is very much greater than a. So look at the diagram. In the diagram, the distance r is, this is a distance r, this is a distance r. If the point P is at very large distance, then this r is very much greater than the distance a. So that is what the special case is. Now if r is greater than a, what happens is the term a can be neglected. Therefore equation becomes E is equal to 1 by 4 pi epsilon naught into p divided by r square plus, instead of a square we should write 0 here because we are neglecting the term 0, I mean a. So that in the denominator we have r square to the power of 3 by 2. So you can cancel square and 1 by 2 here, so that in the denominator you have only r cube. So finally the equation becomes E is equal to 1 by 4 pi epsilon naught into p by r cube Newton per coulomb along px. Now, so general formula. What is the general formula? So electric field due to a dipole at any point around the dipole. So this is the general formula for electric field, for finding the electric field at any point near the dipole, where theta is the angle made by that position vector of point P with the dipole axis. Okay, see, if this theta is equal to 0, if theta is 0, the point P will be along the axial line. Therefore cos theta becomes 1 and 3 plus 1 is root 4. So root 4 is 2. Therefore equation becomes E is equal to 1 by 4 pi epsilon naught into 2p by r cube. Now if the point P is placed along the equatorial line, theta becomes 90 degrees, so that cos 90 becomes 0. Therefore this becomes 0. The 0 plus 1 is root 1. Root 1 is 1 again. Therefore E is equal to 1 by 4 pi epsilon naught into p by r cube. So this general formula is used when We have a point P anywhere around the dipole.